I'm Ashton Addison from Blockwest Capital for Investment Pitch Media. And today on the Crypto Coin Show, we have Kenny Lee, the co-founder of Manta Network. Kenny, welcome to the show.
Hi, Ashton. Thanks for having me.
You're very welcome. Excited to dive into Manta, what you and your team have been building, modular blockchains, about ZK, zero knowledge proofs, and the road to mainnet for Manta Network. I'd love to just kick it off from the top for those who aren't familiar or want an in-depth explanation of sort of what is Manta Network, and then we'll dive into all those details.
Yeah, sure. So Manta Network, we are building a modular ecosystem specifically for ZK-enabled applications. And so what that really means is, we really want to make it as easy as possible for any developers that are building Web3 applications to have ZK-enabled features added into their apps without having to worry about the cryptography side, without having to worry about the circuits. Just focus on your applications. And we provide those sort of ZK features, almost like ZK as a service. Happy to dive a lot more into the details there.
Very cool. And I would love to dive into that just for sort of like a layman's terms of like, does that mean, when you say we want ZK and everything, does that mean it's going to be more private? And if so, like how exactly does it make it more private?
Yeah, really, really good question, because it doesn't necessarily mean privacy in the sense of more so just general sort of control over confidentiality. And I'll give you an example here, because when most of people think about like ZK, it falls into one of two buckets, right? There's the infrastructure layer, which is really on the rollup side. So ZK rollup, ZK EVM, right? Which doesn't really have to do with privacy at all. It just has to do with batching transactions and speeding them up and verifying that those batches are correct. And then there's the second bucket, which is around user privacy. And this is where we think about Zcash. This is where we think about Tornado Cash. This is where we think about, individual user privacy for on-chain transactions. So when I make an ETH payment to you, Ashton, then, the world can still see something happen, but they don't see who made it, who it was sent to, how much was sent, what was sent, et cetera, et cetera. And so that's the on-chain privacy side that ZK is also well known for. There is a third factor here that is less well known, but definitely very much, I think, tangible and a very big need in the market, which is on the application layer use case side. So the ZK enabled application layer. And what I mean by that is it does encompass, some forms of the privacy payment description that I just described, but also beyond that, I'll give you an example here. So ZK enabled for on-chain gaming. If you think about games today, Web3 games, right? Most of it is off-chain, and then there's some like NFT or crypto element to it. So it's this hybrid of like off-chain, on-chain, because there's some issues with creating a fully on-chain game. And so here's the example, right? Like if you and I play chess, it's pretty easy to put it on-chain because everything about the chessboard is fully transparent. Right. So if I say I'm moving my knight to d7, you know exactly where it is. And we don't even have to have a chessboard in front of us. We can just kind of play it in our heads. But the issue with other games, what you describe as imperfect information games, is that you can't have that full transparency. But at that same time, you have to agree on the state of the game. And so that agreement can be done on chain. But if you don't want that full transparency, then you can't put it all on chain. And so an example of this would be any sort of card game, right? Poker. When you and I play poker, we both have to agree on the shuffle of the deck. The way that the deck was shuffled is correct. We both have to agree that the card that you and I received are the cards that you and I were supposed to receive. But neither of us know exactly what those cards are, right? And so there has to be this seemingly contradictory scenario where we have to agree that the cards you received are the cards you received, but we also can't know what they are, right? So that agreement is the consensus layer, which can be done on blockchain, but then you have to add that layer of privacy in a peer-to-peer manner that both people can agree in a trustless sort of fashion that it actually is what it is. And so that's where the ZK comes in. And so by combining ZK onto the application layer, now all of a sudden you are able to build games like on-chain poker, on-chain blackjack, on-chain board games, on-chain strategy games with fog of war. And so that's that third category of ZK use, which is specifically on enabling it on the ZK application layer so that developers can build these like new use cases that aren't seen before.
Wow, very cool. And I feel like there's a lot of different advantages that are like 2 or 3-fold, especially for gaming, which I want to dive into a little bit later. But I want to go back to what you were just talking about on the privacy side for personal privacy, whether, you know, like that we've seen in privacy coins in the past. And I'm curious on how exactly that would work with Manta Network, whether it's isolated to like a Manta coin or you can use any coins, and how it would work, for example, if I, you know, wanted to send some Ether, as you mentioned in the first example, to a friend. What would that look like if you were using it on Manta Network in terms of the currency and the process?
Yeah, so good question. So there's 2 parts to this. The first part is, so actually, let me take a step back. We have on Manta Network 2 networks. One is our layer 1, which is referred to as Manta Atlantic, and one is our layer 2, which is referred to Manta Pacific. And so on Manta Atlantic and Manta Pacific, both are capable of on-chain private transacting. For Manta Atlantic, there is what we refer to as a ZK address system as well as ZK assets. And so it's pretty standard. You can bridge your assets into the L1, and then from there you can privatize said assets and send said assets over to other recipients in a fungible manner. And so with that, right, like the process is very straightforward, and this is for all sort of crypto assets that the L1 supports. On the layer 2 side, we have what we refer to as universal circuits. And so universal circuits are really the bread and butter of how our ZK application layers work. And so what we've done is we've gone ahead and built generalized use cases for specific ZK circuits. And these circuits can be called by developers using SDKs. And those developers can then add those circuits into their smart contract, and then bam, right? All of a sudden you've got specific features that have ZK or specific ZK enabled features. So on the layer 2, it's really up to the application what types of private payments they support, how they support those private payments, which assets, et cetera, et cetera.
Okay, that's great to know. And speaking of on the application layer, I'm curious about launching applications or building applications on Manta Network. You know, there's millions of developers in the world in traditional Web 2, but there's not as many in Web 3 yet. And I know all these networks are trying to lower the barriers to entry to get more developers either from Web 2 to come in, or from Ethereum and Solidity developers to be able to easily launch, you know, where the network effect is of the most applications onto their chain, Manta Network in this case. Could you talk a little bit about the developer ecosystem and how it's going to be easy to launch applications on Manta Network?
Yeah, so short answer is it's very easy to launch applications on Manta. So one of the reasons why we built our layer 2 the way that we built it is so that it's extremely easy for developers. So when we look in the ecosystem right now and look at like ZK application layers, one of the issues here is that there's a barrier to entry, and that barrier to entry usually comes in the form of having to learn a new language. So you have to learn a specific language to build smart contracts that are ZK enabled for those existing ecosystems. For us, you know, we didn't want to do that because there's various issues here. One is like vendor lock-in, right? So if I build an application specifically for your ecosystem using your language, then if your ecosystem somehow doesn't, you know, work out, doesn't have the users, doesn't have the volume, then I'm stuck on that ecosystem, right? I can't just port it over to somewhere else. And then on the other hand, right, like we also have, we're also very focused on the modularity aspect, specifically with data availability, to lower the cost for the end user. Because with modularizing that, all of a sudden the gas fees can be significantly reduced. And for ZK applications, gas fees have historically been sort of an issue. And so what we're doing is with the ZK side, the developers, we're allowing them to build their applications fully on Solidity. What that means is, if for one reason or another, one day they decide, okay, Manta is no longer for me, then they can still port those applications to other EVM compatible ecosystems. And so this is much more of an interoperable, composable scenario. And then from the user side, right, being able to use ZK applications on Manta, not only is it fully available through MetaMask because it's EVM native, but also the gas fees are extremely low. In terms of the actual development, I had also mentioned, the SDKs that people can access to enable ZK features. And so I do want to kind of quantify this a little bit. So if you are a Solidity developer and you are building a game, a very simple card game, and this card game is where the deck gets shuffled, one card gets handed to you, Ashton, one card gets handed to me, and then we both place a bet before we reveal our cards, and the highest card is the winner. That sort of very simple scenario, if you wanted to build it from scratch, including compiling the circuits and everything, right? That's like 1,000, 2,000 lines of code. If you use our SDK, you can build that same exact smart contract with all the functionality I've just described for about 30 to 50 lines of code. So wow. It's a significant reduction, not just in terms of the code base and management of the code base, but also the time it takes for a developer to really understand, circuits, cryptography, DYOR, these types of languages to compile into smart contracts and everything. It's a fairly complicated process, and we're here to simplify everything.
That's amazing to hear. And I think people that they don't have these SDK libraries, or in this case with the ZK involved, it's like starting from scratch every time, and just could imagine how laborious it would be. Yeah. And I feel like we need this kind of standard for, especially if we're gonna start getting blockchain and ZK technology into gaming, for example, they're gonna wanna have, everything preset to go on, like, this is the standard of, especially if we want to have interoperability between games as well.
Yeah, and that's a really good point, because at the end of the day, everyone's reinventing the wheel, but we're all building the same wheels, right? It's the use cases are pretty, you can bucket them into different categories and provide them as a service. It's the same for any sort of software as a service that you see today, right? So accounting, I wouldn't say no one, but most people probably don't do accounting on notebook paper and then calculate their taxes by hand anymore. You've got software that does that for you, because everyone needs accounting in some way or another. Yeah, sure, it varies state by state or country by country, but at the end of the day, a balance sheet is a balance sheet, right? An invoice is an invoice. And so accounts payable, accounts receivable, it can all be serviced. And so it's the same for us for ZK. And that's why, for our testnet, for Manta Pacific, we've launched it about a month now, and we've seen about, I believe, around 80 to 100 verified contracts already deployed. There's been around like 170,000 wallet addresses testing out around like 2 to 3 million transactions so far. So it's just been extremely easy to use, is the feedback that we've seen. On the developer onboarding side, we see them onboarding their applications, existing applications, in a matter of just days. So yeah, we're just here to try to make it as easy as possible.
Wow, that sounds like an incredible start to the testnet. And I was going to ask about all the moving pieces and what's the timeline of getting it out. I'm guessing you guys have been working on getting the testnet out for quite a while, and sometimes these protocols have to be tested for quite a while before they hit mainnet as well.
Yeah. So we've been at this for about 3 years now. So it's been quite a journey, because when we started, we were specifically focused on our layer 1. And the reason why we were doing this is because, we wanted to provide the best user experience when it came to ZK applications. And you can't just natively do that on EVM. And just to kind of give you an example here, doing a ZK transaction on Ethereum for like privately sending assets to other users. At the time when we were trying it out, it was around like $50 to $100 round trip. And so that's a financial barrier for most users, right? And so the issue that emerges here is you have a selective bias. you only have users who not only have the funds necessary to not care about that $100, but also the reason why they're using it has to be way more than $100, right? And so this selective bias ends up having this sort of, I guess, leaning towards not everyday use, but more so, certain limited use cases, which kind of conflate the idea that there's more nefarious use cases for privacy, which is why people are like, oh, I don't need privacy because I'm not doing anything bad. But if you were able to enable privacy for users and remove that financial barrier, then you would be able to really escalate those use cases, right? Because now you have fully on-chain payroll, right, that you can do around the world and no one has to worry about that. There's just one sort of use case there. And so in order for us to do that, we couldn't just build directly as a smart contract. We really needed to optimize. And so we needed to build as an L1. And so that's what we really focused on first. And then this layer 2 that we've released, the modular layer 2 that uses, fully EVM native environment, that was released about a month ago. That was also about 6-ish months in the making. But that was, sped up in terms of how we could deploy because of all the work that we've already done on the optimization and the ZK side previously. And so now it's just a process of getting as many applications onboarded as possible, getting our contracts audited, getting our network audited. And then from there, we're looking towards pretty, hopefully, successful mainnet launch.
Very cool. Great to hear. And speaking of, protecting privacy, and you mentioned, it could be for nefarious uses. Most applications where you're submitting a lot of funds, they all have a KYC process nowadays, even in Web3. And I know that there's ways to improve that, and I know Manta is working on some kind of technologies to improve at least the privacy protection part of KYC, because people have no problem giving out their information to verify who they are, to get involved in a project, or to send a large amount of funds. It's just a matter of when you give over that personal information, who exactly are you giving it to, or is it stored in a secure way? And from what I understand, the ZK technology can help with protecting people's privacy. I know in the earlier days of Web3, there have been people who gave over their KYC information and it was in an unprotected way, and then that was exploited, or we're still seeing phishing scams or people trying to siphon out people's information. So how exactly is this technology that your team's building helping with the KYC procedure?
Yeah, so thanks for bringing that up. So the ZK SDTs is something that we developed approximately, I don't even remember how long now. Time just is relative, but it's a technology that we released a while back, specifically focused around verifying on-chain identity in the least intrusive way possible. And one of those use cases is specifically around KYC and on-chain identity. And this is just one of many things that we are working on because, at the end of the day, we definitely want to make sure that, we're being as safe as possible with the network, with the users. But so for the ZK SDT side, so you already have these instantiations, these attempts at on-chain KYC that you just described, Ashton. Binance being one of those. So Binance, if you're KYC'd on Binance, they will issue you an account-bound token, a Binance account-bound token, which is a soul-bound token linked to your address. So you can use that soul-bound token, go to the other applications and say, hey, I'm a good actor. I've been KYC'd on Binance, right? And so the issue with that, though, is that that's still fully public. And so if I went to a DEX and I verified to the DEX that I was, KYC'd through Binance, okay, that's great. But now the DEX also sees my wallet address and they see my net worth. Right. And these types of services, you can probably extrapolate the potential vulnerabilities there if now I know who you are and how much money you have and all these your willingness to spend and how that could be, used against you. And so we created the ZK BAB using our ZK SDTs. So our ZK SDTs are just privacy enhanced soulbound tokens. And so you're able to still verify that you've been KYC'd on Binance, but at the same time, you don't have to reveal your wallet address or any of your other assets. And so now you have this trustless, fully verifiable on-chain identity that doesn't reveal anything else about you. And Binance is just one of those sort of KYC mechanisms. We also have Galaxy as a partner, and we're partnering with other sort of KYC services as well. So that's all an attempt to, help users transition over to, on-chain, fully on-chain identity in the most safe manner possible. We've seen about, I believe, like 150 to 200,000 users KYC through those ZK
Wow, that's very cool. And yeah, I was curious about that. So thank you for helping the privacy procedure, because yeah, it's, all of this with these layer ones with, from the infancy, having no protection, where you send $5 to somebody and all of a sudden they can see everything that you own. And especially if it's a new DEX or people that are speculating on new applications, sometimes those applications don't always make it, or maybe they're in the good hands, but eventually there's a vulnerability there and someone breaks in. If it's not directly into your wallet, it's through an application that you used. And there's still a lot of, in the decentralized world, people are approving contracts that they don't always understand exactly what's in the contract, and that there's potential to siphon funds or anything like that. So I feel like this would be a great help for decentralized exchanges or anywhere where you're going to be trading.
Yeah. And I hate to admit it, but I've also been victim to these types of attacks. It's really hard to keep an active mind about it every single application you interact with, and I think this is more so a general issue with the Web3 ecosystem right now, which I think you've probably heard it a million times by now, but user experience, right? And it doesn't matter if this is your first time sending assets or if this is your 1,000th time sending assets. It's always very nerve-wracking. You're always, kind of on edge thinking, did I send it to the right place? Should we send a test amount first, right? And so these types of complications, the complexities can lead to a lot of sort of opportunity for vulnerabilities that I think in general need to be solved. And so and that's exactly what we're doing as well, right? Like at the end of the day, our approach is through ZK, but I think our mission is really to just simplify the user experience as much as possible. Yeah.
Well, thank you for doing that. And now flipping back to the positive side, sounds like there's great work so far on the testnet launch. I would like to know if you're just looking at developers launching more applications, or if there are users that can in some way contribute to the testnet or get involved prior to this mainnet launching down the road.
Yeah, so with the developers, they're launching the applications, but with the users, it's very important to start getting as much feedback as possible to know what types of applications people like, and also a lot of the developers that we're working with right now, they want that feedback as well, and so that's a great way to help them improve their applications. It helps us improve and monitor our network as well. And so there's a lot of ways for users to get involved. If you just head over to our website or our Twitter, you'll get a link that can give you a whole guide on all the different activities, all the different applications, how to use them. And so that's a great place to start.
Amazing. And I can leave those notes, links to that in the notes below as well. Kenny, is there any last words you wanted to mention before we wrap up about Manta and how to get involved, or what's headed next in the future?
No, I think that was very comprehensive, and thank you very much again, Ashton, for the time. Really appreciated the conversation, and I think we got through a lot of interesting points.
I completely agree. Thank you so much, Kenny. All the best with everything in Manta Network moving forward, and let's follow up in the near future.
Thank you. All right. See you later.